Okay, in this video, we are going to study how to calculate the mean or the average. So before doing so, I would like to first clear up the, the terminology. So there are different names for the same object in statistics. Average is more casual way to call it, and mean is a little more statistically like a more like academic or official formal term in statistics. And another term is expectation or expected value. By the way, I think I'm going to use expectation or expected value more than mean and average later, because expectation is a more rigorous and more academic term that refers to this object. And so you may understand the mean is a specific form of expectation. So expectation can be taken on more different objects, but mean is just special way to think about expectation. But anyhow, but in this course, these three terms are pretty much the same thing. And I guess there is no reason to be confused. They are the same thing. But the notation is from expectation, because, as I said, it's more academic way to use expectation. So the notation is coming from E, expectation E, and it denotes the expected value or expectation of a random variable x. Expectation of x. It is the mean or the average. They are the same thing. So don't be confused. So let's think about a simple example. Here is a lottery with this probability distribution. Just it's if you buy this lottery, you can win $100 with 1%, and 99% you get nothing, right? Typical lottery. So and a typical way to calculate an average is like this. You may win 100 or 0. So the average is 50. Is it right or not? The mean is 50 because there are two outcomes, and 50 is the average. Of course, it's not. It's not right. And you may have thought this way, but it is wrong, because you are treating 0 and 100 equally, but actually they are not equal. They have different probabilities, and 0 is much more likely than 100. So you have to utilize the probability to adjust their likelihood, right? So that means this is not the mean. It is not the mean, but the mean is the sum of probability weighted outcomes. You have to understand this. It is a kind of sum of probability weighted. This is the point. You have to put more weight on more likely outcomes, but unlikely outcomes will get a lower weight, which is natural. Okay, let's go back to our previous example, Academic Excellence Award example, comparing students. So now we are going to study how to calculate the mean. You may think it's obvious, but I have seen a lot of students who are still confused how to calculate the mean, because there are two different ways to calculate the mean. So there are two different ways to present the data. So there are two different forms of information, and depending on what kind of information you get, you have to use different methods to calculate the mean. It's like this example. This method is correct in some cases, but it's not correct for this data, this information. So the reason is there are two different ways to represent a data, to present a data. One way is to give you a raw data. In the raw data, I just list all the outcomes. It's like Excel file. Actually, you don't need to worry about anything. This is a typical data you have in mind, and this is how you calculate the mean. And the second way to summarize, to present a data is based on frequency or probability distribution table. And it is already manipulated, already processed and summarized information, right? So outcomes in here, in this table, by the way, those two are the same information in the end, same data, but in this case, outcomes are ordered clearly, cleaned, and their frequencies, counts, number of realizations are listed here. So outcomes are here, and these are like frequencies. So it's different, and those two columns have different roles. In here, our previous definition is more useful because in the end, the frequency will become probability, and use those frequencies to put weights on those outcomes. So for example, 2.7 is a possible outcome, but actually it did not happen. So it should get 0 weight. So its weight is 0 because it never happened. And 3.7 happened most frequently, so it will get the highest weight. In that way, there is an additional step to calculate the mean. So we are going to do each of the two methods. First, when you have raw data, it's pretty simple. There is nothing special. This is exactly what you have in mind and what you learned. And suppose that the data are given as x1, x2, xn, the general form of data. You just have n number of observations. In this case, we can apply the definition of the mean. The mean is the sum of probability weighted outcomes. Probability weighted outcomes, so we have outcomes, but where is the probability? We don't have probability. We only have n outcomes, but what we assume that all observations receive the equal weight. There is no probability, and we just happen to have like this number of observations, so there is no reason to treat them unequally. So we are going to assume their weights are equal. All the guys receive the equal weight, which will be 1 over n, because there are n number of outcomes, so each of them will get 1 over n. So x1 is weighted by 1 over n, x2 weighted by 1 over n, and any observation is multiplied by 1 over n. So, and then they are going to be summed. You have to sum them, like so. Each of them is a probability weighted outcomes, and sum them. And then in the end, you get this, and this is the average formula you learned maybe in high school or earlier in other classes. So in the end, it's like sum all the observations and divide by the number of observations, the sample size. So still in this formula, we can our definition of the mean applies, the sum of probability weighted outcomes. But just remember, in this case, probability is hidden because it's equal. All the outcomes get the same probability. Right? Back to our example, numerical example. Sum all everything and divide by 10. So there are 10 observations and sum and average. Nothing special, right? And this is like when you have an Excel file, this is how you calculate the average and how Excel calculate the average, right? So later, I'm going to show you how to calculate the average on Excel, like after we study other measures, right? Okay, this was easy, but now, what happens when you have a probability distribution table? It's a little bit more complicated, but just remember the definition. The sum of probability weighted outcomes. So this part is the probability distribution table. Probability distribution table is this part, and you have outcomes, you have corresponding probabilities, and then what you have to do is you have to calculate the probability weighted outcomes, which is outcome times probability. So multiply the probability to its outcome, and then for each outcome you get one probability weighted outcome, and then as many as the outcomes, you are going to get the same number of probability weighted outcomes. Then sum all of them. This is the expectation. Probability times outcome plus probability times outcome, da 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 da. In the end, summation. By the way, just in case, if you, intentionally I use summation instead of integration. In case if you understand that the integration is a generalization of the summation, that is a better way to understand it. So you may replace it as a integration. Replace the summation with an integration. Still, that's a more general way to define the mean. But I'm not going to use the integration because some of you may not be familiar with integration concepts. Anyhow, the point is sum of probability weighted outcomes. So you have to calculate probability weighted outcomes first and then sum, right? That's as simple as that. And come back to our numerical example. Frequency table is given. What we have is our frequency table. And remember, this is the different format from the raw data. Raw data was just a bunch of numbers, but it is already summarized, already processed, manipulated information. In this case, what you have to do is calculate the probability first. Convert frequency into probability. You know how to do this, right? So there are a total 10 number of observations, and then out of 10, 4.0 happened once. So probability is 1 over 10, and 4 times 4 over 10, 3 times 3 over 10. That way, you get probability. And once you get probability, you don't need frequency. But what you need is probability weighted outcomes. So you have probability, you have outcome, so it is easy to calculate probability weighted outcomes. Multiply outcome to its probability and write down in another column. And outcome to its probability and make another weighted outcome. That way, we are going to make an additional column that lists the probability multiplied by the outcome. So 0.4, 1.48, 0.99, 0.6, 0. And then sum all these guys. Sum these 5 numbers, like actually sum 4 numbers, 0 excluding 0. Sum those numbers, then you get 3.47. This is the mean. Again, the definition is the sum of weighted outcomes. Sum of weighted outcomes. Compare this to this. Of course, they have to be the same. Yes, they are the same. If they are wrong, they are different. Something is wrong. You are wrong. And I don't know if this function is built in Excel, but I don't know any function that converts probability distribution into mean. So Excel does not understand the probability distribution table, I think. So this is a new way, like you need to understand, right? My last comment is in the so far we considered as if a finite number of observations are possible, but it doesn't need to be finite. We can imagine an infinite number of data, just of course only in our imagination. But like when we say true mean or true probability, that is based on this imaginary infinity world, right? World of infinity. So that is called population. And as opposed to the population, we call the finite world as the sample. Sample is the data. And so, like if you imagine an infinite number of observations, then you can naturally define population mean and population probability. Like probability was from chapter 1. So anyhow, population mean can be defined in the same way. But so far, of course, in our example, I have to show you an example. So I have only show you the sample mean. So that was sample mean based on finite observations. So population mean, so we can define population mean and sample mean. And in population mean, method 1 is not possible. Like it is possible only when you have infinite number of observations, which does not exist in the real world. It's purely imaginary conceptual work. But still, you can calculate the population mean if you have the population probability. If the probability was population probability, then the resulting method, the resulting mean is the population mean. Again, this is the true mean we would like to know in the end. And it is usually denoted as Greek letter mu. On the other hand, sample mean is like what I showed you. Based on finite data, you may use method 1 or method 2. And in method 2, if you use sample probabilities, then you get sample mean. And it is denoted as X bar. It is X bar. So I'm telling you they are different because like in the end what we are going to do is, so for example, we don't know what is the average. So we are wondering what's the mean hourly wage in the United States. How much the consumer price index increased. Consumer price index is a kind of average of a lot of prices, right? So how much it increased. Then our question is about population mean. What is the true mean? How much is it? But population mean is impossible to observe. So we are going to estimate the population mean using the sample mean. Population mean is in the world of infinity. That is our target. But we, of only use the sample. So by considering the population mean, we can define the error, how much error our estimator has, and how accurate our estimator is, something like that. That's our main goal in like chapter 9, 10, 11. So I want you to understand, distinguish the role of population mean and sample mean from now on, so that like the reason why we study this is to do some kind of statistical inference. So we need to understand and distinguish them for later chapters, because that's the what we actually want. Okay, so I briefly gave you how to calculate the mean in two different ways depending on the format of the information. And in the next chapter, in the next video, I will extend the mean a little bit. So it's related, so continued method, but there is a minor some generalization. See you in the next video.